So in this video, we're going to talk about simplifying rational expressions. So first, let's recall how do we divide two fractions. So we keep the first one, we change the division sign into multiplication, and we flip the second fraction. In other words, to divide two fractions, we multiply the first fraction by the reciprocal of the other one. Now we have a complex fraction and we need to simplify it. So we're gonna use the idea of keep, change, flip. So we're gonna keep the first fraction, we're gonna change the division sign into multiplication, and we're gonna flip the second fraction. In other words, we're writing the reciprocal of the second fraction. And I notice by doing that, I can simplify the 3x. Also, I can simplify 12 over 3, and that's 4 over 1. Therefore, the final answer is 4. I can do it also from here. I can simplify 3 over x, and I can simplify 12 and 3 to give me 4. Another example of a complex fraction, and we need to simplify it. So we're gonna write this complex fraction as the division of fractions. Now we're gonna use the concept of keep, change, flip. I notice x minus 1 can be simplified, and therefore the final answer is 7 over x. I can also without changing anything by simplifying x minus 1, and therefore the final answer is 7 over x. Now we need to simplify this fraction. So I notice the least common denominator is 9 here. So we're going to multiply the top part by 9 and the bottom part by 9, because that's my least common denominator. Now we're going to distribute the 9. So 9 times 2 is 18. 9 times 3 over 9, that's 3. 9 times 3, that's 27. And 9 times 5 over 9, that's 5. Therefore, the final answer is 21 over 32. Now the least common denominator here is 5x. So we're going to change everything into a denominator of 5x. Or we can multiply 5x by every term. So 5x times 1 is 5x. 5x times negative 8 over x is negative 40. And 5x times x is 5x squared. And 5x times 4 over 5x, that's 4. And there's nothing can be simplified here. So the final answer is 5x minus 40 over 5x squared plus 4. We have another complex fraction. Now if we look at the denominator, we have 4 over y minus 1 over x. So we're gonna change the bottom part with the denominator of xy. Now I can cancel xy from every term. Now the top part is a difference of 2 squares. So we need to rewrite this one as a difference of 2 squares. And then 4x minus y can be cancelled. Therefore, the answer is 4x plus y. Another example, and we need to simplify the given complex fraction. So I notice my least common denominator is x squared. So we're going to change every term into denominator of x squared. So we're going to end up with 5x plus 1 over x squared over 25 minus x over x squared. The x squared can be simplified. Therefore, the final answer is 5x plus 1 over 25 minus x. Another example, my least common denominator here is x squared. So we're going to change every term into the denominator of x squared. So we're going to change every term into the denominator of x squared. Therefore, we're going to get x plus x squared, 3x squared, over x squared, over 1 minus 9x squared over x squared. The x squared can be simplified. Now from the top, we can factor out x, and the bottom is difference of 2 squared. Therefore, the final answer is x over 1 minus 3x. So keep in mind the simplification. Another example, my least common denominator is 9x. In this example, my least common denominator is 9x. So we're going to change everything into the denominator of 9x. Therefore, we're going to get x squared minus 9 over 9x over 9x minus 27 over 9x. The 9x can be simplified. Now we're not done yet. Notice in the bottom we can factor out the 9, and the top part is a difference of 2 squared. Therefore, the final answer is x plus 3 over 9.